Okay, so now you've got a worksheet. It's got 6 sketches that you can try, and then 6 where you're asked to try and find the equation. I'm going to let you and your class decide if you want to watch this, but I'm going to answer the first question in each row. So you might want to just work ahead on it and try it on your own, then come back and push play and see how you did. Or you can just watch, not make any notes, and then try it on your own later. I'll let you guys decide how you do this. But I'm going to do the first question in each row. All right. So the first one is y equals 2 to the x plus 1 minus 3. First off, we recognize that this is an exponential function. And then we see we've got a plus 1 here, which means it moves left 1. And the minus 3 moves it down 3. So now I've got to try and draw the exponential function. So I'm going to start with the original. Remember, the exponential function goes through 1, and this, and this, and this, and this. Sketch that lightly. And now I got to move it left 1 and down 3. I'm going to start with the down 3 part because remember there is an asymptote right here for an exponential function, and it moves down 3. So I'm going to do 1, 2, 3, and I'm going to leave that asymptote there. Then I'm going to look at some of these points, particularly this point here, and move it. And I move it down 3 and then left 1. So if I go down 1, 2, 3, and over 1, I get this spot. This one here, down 3, 1, 2, 3, over 1. This one, 1, 2, 3, over 1. And I'm starting to get the picture of my curve. And this one is y equals 2 to the x plus 1 minus 3. You can try it then on the other 2. Next, because the log comes a log function. So again, you can pause the video if you want to try it on your own, or we'll just go to it right now. So it's a log function, and we look inside the function, it's plus 2, so that means it moves left 2, opposite to what we think. And then the minus 2 tells me it moves down 2. So I'm going to draw this graph. And this one, if you remember, goes, instead of going through 0, 1, it goes through 1, 0. And this one, and then these half points. And we get the inverse function, which of course is the log function. It doesn't have a horizontal asymptote, but it has a vertical asymptote right there. So this is all drawn lightly. As a reference point. Now I'm going to move it left and down. Well, remember the asymptote doesn't change when I move it down, but it does when I move it to the left. 1, 2. And I'm going to take these points and move them left 2, downward 2. So here's the spot here. It moves 1, 2, left 2, and then down 2. So there's that spot. This one, 1, 2, down 2, boom. This one, 1, 2, down 2. And we end up with this curve. And that is the y equals log base 2 x plus 2 minus 2. Really then, I know we watched 40 minutes of video here, but that's what I expect you to do at the end. Be able to take the exponential function, recognize what it looks like, shift it left, right, up, or down, maybe flip it. And the logarithmic function, the same thing. Remember what it looks like, shift it left, right, up, down, maybe flip it. So there's the first 2 sketching ones, at least the first 2 in the rows. Now I'm going to talk about how I get these ones. Again, if you want to pause the video, you can and try them and come back, or we'll just go on. You should know that all of these ones are exponential graphs. And all these ones are logs. So that's what you started with. Now we got to figure out what it is. So for these, First thing I think you should do is try and find the asymptotes, because if you know where the asymptotes are, you know whether it's moved left, right, or sorry, up or down. So if we look at this graph, you see there's an asymptote right there. We know the original graph of this exponential function would have had an asymptote there, but since it's down here, you know that it's moved down, and how much? Well, you know that it's moved down 3. From here, 1, 2, 3. You should notice too that there's a dot that I've purposely colored in on each of the graphs. That's your reference spot. Remember, this one is referring to where the original was. The original was right here. So if we think of the original magical spot there, 0, 1, now we can count where it moves. So it's moved 1, 2, 3, down 3, which we knew, but it's also moved to the right 1. So this point here tells me that it moves right 1. When I took those two bits of information together, and I know it's an exponential function, it's y to the 2, and now right 1 means up in the brackets I gotta have x minus 1, opposite to what I think, and then down 3 here is minus 3, and I guess I could have written it down on the space. So then the other exponential functions right here and right here, you assume that it's y equals 2 to the x. We're just going to pretend that all of our graphs are 2 to the x, not 3 to the x or 4 to the x. And then you figure out where your asymptote is to know if it moves up or down, and then where your reference point to see if it moves left or right. Similarly, on these ones, we're going to look at the logarithmics. So again, you can try them and pause the video if you want, or we can go straight to it. So first thing I'm going to do on this is recognize that it's an exponential, and I'm going to draw the horizontal asymptote, or sorry, vertical asymptote. So I can see that there's a vertical asymptote here. This asymptote is moved. It used to be here on the regular logarithmic function, but it's moved all the way over here. How far over did it move? Well, it moved left 4 units. The other thing you'll notice is that the graph is going in the opposite direction. Remember, the logarithmic function usually goes like this, but this one looks like it's been flipped. So even if it's moved over here, it definitely looks like it's been flipped up or down. So how do I deal with the graph that's being flipped? This one's been flipped up or down. So that up or down, of course, is outside the function. So I'm going to put a negative outside the function. So I'll deal with that in a moment. And then last is that point. That's magical point again. You'll see in this case, I've colored it in over here. It's referring to where the original one. The original does this. So the original spot is right there. So the question is, how does that spot move? Well, that spot has moved, and we already know this, moved left 1, 2, 3, 4. Okay, we already knew that. It moves left 4. But now you can also see that it's moved up 1. So now you got to draw a logarithmic function, or write the logarithmic equation that's been flipped, so it'll have a negative on the outside, moves left 4 and up 1. So if I go and try and do that, it's y equals negative out front, log. We're assuming again these are log base 2, so we're just going to put the base 2 there. Left 4 is inside the function, so it's going to be x minus 4, opposite to what we think. Right, left 4 would be a plus 4, excuse me. Okay, opposite to what we think. And then up 1 is going to have a plus 1 at the end. So I've got the flipped here in the negative. I got the left 4, so it's plus 4 inside the function, and then a plus 1 at the end to tell me it moves up. So now you've seen examples on how to do the exponential and logarithmic function and come up with the equations. So you've got a couple other ones to find. These ones and this one are both exponential. These two are both logarithmic. And that's all the work that needs to be done today, is finishing that worksheet. We've listened to enough video today. We've got some examples to do, and now practice with some of those, with the rest of that worksheet. Good luck.